Greenhouse warming theory is rapidly becoming the most expensive mistake ever made in the history of science. Video 6. Global temperatures have typically risen within years and cooled over millennia. The geologic record contains extensive evidence for how climate has changed throughout Earth history, when the temperature changed, by how much, how suddenly, how frequently, and how cyclically. The most widely used method to estimate former ocean temperatures involves measuring the ratio of heavy isotopes of oxygen to light isotopes of oxygen in the shells of tiny little animals. Foraminifera, which are typically less than 1 millimeter in diameter, are a good example. Water containing the heavier isotope of oxygen is hard to vaporize and easier to condense, making this isotopic ratio proportional to the temperature of the water at the time each animal was growing its shell. Geologists have devised ways to determine the ages of these shells based on their species and based on their position in sedimentary layers that are referenced to the geologic timescale. When you take 17,000 of these measurements and average the temperature data for each million-year interval, you get a quick overview of climate change throughout the past 600 million years, shown in red in this figure. Note that ocean temperatures are changing all the time, and that there is no obvious cyclicity. The numbers label the 4 periods of time when glaciers were widespread. These are the only times when extensive evidence of glaciation is found in rocks and sediments. There are longer periods when much warmer temperatures were common. This figure shows ocean temperatures in red over the past 150,000 years, based on a combination of oxygen isotope data from 57 globally distributed deep ocean cores. Note how ocean temperatures cool slowly and incrementally from the Eemian climatic optimum on the left, around 125,000 years before present, to the last glacial maximum on the right, around 20,000 years before present. Vertical black lines show times of all known major explosive volcanic eruptions. Evidence for these eruptions gets harder to see for older periods of time. But note the high rate of eruptions from 40,000 to 20,000 years before present, just before the last glacial maximum. Geochemists also can measure oxygen isotopes in air bubbles contained in glacial ice to estimate changes in air temperature at the time the ice was formed. Since ice layers can be dated to within years to decades, these studies provide the most detailed evidence available for changes in air temperatures, especially in Greenland, where snow falls at a much higher rate than in Antarctica. 25 times in the last 120,000 years, there was rapid warming of air within years, followed by slow cooling over millennia. These sequences average every few thousand years in length, but they are clearly erratic. They are not cyclic. Throughout the geologic record, whenever we observe finely layered ocean or lake sediments with time resolutions better than a few thousand years, we find evidence of climate changing from cold to hot within years, and then cooling slowly, incrementally over millennia, in sequences that average several thousand years in length, but are highly erratic. These sequences are clearly not cyclic. These sequences can be explained most directly by major effusive basaltic eruptions causing sudden warming, and a series of major explosive eruptions causing slow, incremental cooling. Basaltic eruptions are most common in areas of continental rifting and ocean floor rifting. Explosive volcanoes, on the other hand, are most common in regions of plate convergence and subduction. Volcanoes appear to rule climate change. Global temperatures appear to be a delicate balance between the volume of basaltic lavas being formed in areas of continental rifting and the frequency of major explosive eruptions per century occurring in subduction zones. These well-observed erratic sequences in climate cannot be explained by cyclic causes such as cyclic changes in Earth's orbit, cyclic changes in solar radiation, or cyclic changes in sunspots. Furthermore, it's hard to envision how changes in atmospheric concentrations for greenhouse gases could cause such major erratic changes in climate. The only known way to suddenly increase greenhouse gases is with major volcanic eruptions. While Mount Pinatubo is thought to have ejected as much as 200 megatons of carbon dioxide up into the atmosphere, concentrations of carbon dioxide in the atmosphere measured on Mauna Loa in Hawaii stopped increasing for the next 3 years, apparently caused by aerosols cooling the oceans, which then absorbed more carbon dioxide. This figure shows a temporal correlation between temperatures and concentrations of carbon dioxide in air bubbles from ice cores in Antarctica over the past 800,000 years. Most detailed studies of this correlation suggest that carbon dioxide concentrations increase up to 400 years after temperatures rise. This suggests that atmospheric concentrations of carbon dioxide increase as oceans warm and decrease as oceans cool due to the well-known solubility of carbon dioxide in water, plotted in video 10. You observe this phenomenon when bubbles of carbon dioxide rise into the atmosphere as your beer or soda warms. Returning to the figure showing ocean temperatures over the past 600 million years, I've added the best evidence for concentrations of carbon dioxide shown in blue. Note that glaciation was common during times when carbon dioxide concentrations in the atmosphere were 2.5 to 5 times greater than current concentrations. There does not appear to be any clear correlation between climate change and concentrations of carbon dioxide in the atmosphere. Thus, extensive observations of climate change throughout Earth history show that climate has been dominated by erratic sequences of rapid warming within days to years, followed by slow incremental cooling over millennia, and that these sequences can often be as frequent as every few thousand years in length. Climate has been changing at rates far higher than most climate scientists currently imagine. There is no evidence of similar rapid changes in atmospheric concentrations of greenhouse gases. Thank you.